Action.
Hi, my dear students. I want to give you a few quick video lesson overviews of some important concepts as we work through this latest homework assignment and prepare for the next test, where we're covering everything from reactions, compounds, bonding, solution chemistry. And so I've prepared a bunch of examples and sample problems to begin to introduce certain concepts. The first one I want to introduce, the first skill I need you to master, is calculating molecular mass, molar mass, molecular weight, as I learned it many years ago. More correctly for ionic solids, formula weight, because of course you never have just one sodium chloride, it's a crystalline array, and so we take the smallest whole number unit and we have that formula unit mass. And so when we went and previously looked at our periodic table and we looked at atomic mass, you notice those were unitless, and we use this, really want to say made up unit, but it's a construct. In my days we called them Daltons. Today they're called atomic mass units. They're not the formally defined unit as strictly as in your book. In 2017 they redefined the atomic mass unit. So you still have, for example, an atomic mass unit equal to 1/12 the mass of carbon-12. The problem is that now a mole of carbon-12 atoms doesn't strictly weigh 12.00 grams. But the difference is between the old and the new is 3.5 times 10 to the minus 10. So unless you're working out to 8 or 9 places, the difference is not significant. When we looked at our compounds, our atoms, we could look up there and get average atomic mass. That's the average for that element with consideration for isotopic proportions throughout the Earth. So, for example, when I look at iron here says 55.85, and if you notice, it has no units. But now we're going to, and I'm going to, in a minute, start another video lecture on the mole concept and use of the mole map. But right now I just want to tell you how to calculate the molar mass, molecular weight of a compound. So remember, a molecule is 2 or more atoms, a compound is 2 or more different atoms. So this is an atom, this is an element, iron, and we're going to now say that that 55.85 has real units of grams per mole, abbreviated MOL. And here is hydrogen. Now, hydrogen has an atomic mass of 1.008, according to this periodic table that I have in my hand. But that's an atomic mass, and hydrogen is naturally found as H2, sometimes referred to as molecular hydrogen. So molecular hydrogen actually has a mass of, don't forget to double it. So there's 2 of them. And here's your little clue for your periodic table. If it ends in gen, nitrogen, oxygen, hydrogen, or ene, fluorine, chlorine, bromine, iodine, or astatine, those exist in nature as diatomic molecules. So if you're ever working equations and reactions and considering physical quantities of these substances, you need to double the atomic mass to get the molecular mass. So that would make hydrogen 2.016 grams per mole. Now, to find molar mass, and I'm going to grab my calculator. Just keep focusing on that. It's very simple. You need to simply add up the sums of all the atomic masses for all the atoms in that particular molecule. So here's a molecule of sulfuric acid, H2SO4. It's got 2 hydrogens. It's got 1 sulfur. And it's got 4 oxygen. And hydrogen, like I said, is 1.08. So I would have 2 times 1.08. And that would be equal to 2.016. Sulfur, as I look it up here, has an atomic mass of 32.07. 1 times 32.07. 32.07. And finally, oxygen has atomic mass of approximately 16. For our purposes, for 2 significant figures past the decimal, it is going to be 4 times 16.00, which is equal to 64.00 grams. And then when we want to know the molecular mass for sulfuric acid, we simply sum all the atoms up. 2 hydrogens, 1 sulfur, 4 oxygen. So right here, 6 and 7, 13, carry my 1, 2, 2, 4, 8, and 3 and 6 is 98.23 grams per mole. So if I want to know the molecular mass, I simply take my atoms, look their atomic weights up, atomic masses, sorry, I'm old, up in the periodic table, and sum them. Now here's one other complication, the same way we could look up just iron. We could look up hydrogen, but hydrogen exists as H2, so we need the mass of molecular hydrogen. So this was my molar mass for my sulfuric acid. My molar mass for my iron sulfate, more correctly, my iron 3 sulfate, okay, because sulfate has a -2 charge. There's 3 of them for a total of -6, so my 2 irons must have a charge of +3. So this is iron 3 sulfate is its proper name. In this case, I need to remember that this sulfate is a polyatomic ion, and the SO4 2-, there are 3 of those. So to calculate this one, I need 2 times iron. So if I bring this down here, I can calculate that mass. 2 irons is equal to 2 times 55.85. And I need, this time, 3 sulfurs. Okay? Because there's 3 of these sulfates and each has 1. So I need 3 times sulfur, which is equal to 3 times 32.07, which would be equal to 96.21. Okay? And then I have 12 oxygens. Each sulfate has 4. I have 3 sulfates, so I would have a total of 12 oxygens, which would be 12 times 16, which would be 16.00, which would be 28, 186. I'll check it with my calculator here in a minute. And so if I sum these, and I need my calculator to double check my math, 55.85 times 2, which would be 111.70, and oops, this was 192. 192 grams per mole of iron 3 sulfate. So 192 plus 111.7 plus 96.21 is equal to 399.91 grams per mole. And that is how you calculate molecular mass for a compound. You take the atomic masses of the individual atoms, you multiply it by the number of atoms in the compound, and you sum it up all together. That's step 1 in working all the problems we're going to visit next. See you in the next video.